This is the screencast for section 3.7, example 2. We're going to find the slope on a circle, which we were not able to do until we know how to do implicit differentiation. So we're going to find the slope of this circle whose center is at 0, 0 and whose radius is 5, specifically at the point 3, negative 4, which is right here. You can see the tangent line drawn there. We're trying to find the slope. So we'll take the derivative. The derivative of x squared is 2x. The derivative of y squared is 2y. Now, unlike dx dx that cancels out, dy dx does not. And the derivative of 25 is 0. So I'm going to solve for dy dx in order to come up with a good equation to find the slope. And I get that the equation to find the slope would be the opposite of the x-coordinate divided by the y-coordinate. So I want to evaluate dy dx at 3, negative 4. So I need both of those coordinates, and I get the slope is 3/4, which I could make the equation of the tangent line and check this on my calculator if I wanted to. The now try problem number 11 also asks us to find dy dx and the slope of the curve at the indicated point. Alright, well, we have the circle, it's the equation of a circle here, whose center is at 1, 1, whose radius is square root 13. They want us to find the slope specifically at 3, 4. So I'm going to find dy dx first. Do I have to use chain rule here? Let's see. The derivative of x minus 1 squared is going to be 2 times x minus 1, and then times the derivative of x minus 1 is just 1, so no, I don't need to use the chain rule. And then of course I have dx dx that cancels, plus 2 times y minus 1, and then the derivative of y minus 1 is going to be dy dx minus 0. Equals the derivative of 13 is 0. Now I'll solve for dy dx. So subtracting the quantity with x and then dividing the quantity with y, I get negative x minus 1 over y minus 1, and it's asking me to find, so that's dy dx, I found that part. Now it's asking me to find the slope at 3, 4. So dy dx evaluated at 3, 4 is negative 2/3, and if I drew a little tangent line there, it definitely does have a negative slope. Negative 2/3 seems reasonable. But again, I can make the equation of the tangent line and graph it to check for sure.